Hey everyone, in this video we're going to talk about conditional statements. So through this whole unit of logic we've been talking about if and then statements, and that is exactly what a conditional statement is. If you look at this definition here at the top, a conditional statement is a statement that has an if and then in it. It is called a conditional statement because in order for something to occur, a condition must be met. Okay? You can go to the game if your room is clean, right? Something must be met in order for this conclusion to be true. So your hypothesis, we call this beginning part the hypothesis. This P is your hypothesis. Let's see. And then we call the Q the conclusion. So we have if hypothesis, then conclusion. And if the hypothesis is met, right, or if this condition is met, then you can conclude Q. You can conclude this conclusion. So I'm going to walk you through an example about conditional statements in general. And then what I'm going to do is I'm going to show you what we're going to be doing with these conditional statements. So when you look at this conditional statement here, if it is raining, then I will carry my umbrella, right? So the hypothesis in this section is everything right after the if. If it is raining, that's P. Then I will carry an umbrella, that is Q. If and then are the things that allow me to figure out what's a condition and what's a conclusion, right? What's the hypothesis, which is P, and what's the conclusion, which is Q. So everything right after if is P, or the hypothesis. Everything after then is Q, the conclusion. Now, what we're going to be doing with this conditional statement is we're going to be talking about related conditionals. And we have three different types of conditionals that we can manipulate. We're going to manipulate this P implies Q, and we're going to move the order around. We're going to negate it and do both of those things in order to see what the statement becomes. By manipulating this conditional statement, we're going to create three different statements, and in that point, our goal is to analyze and verify its validity. Is it true when you move it around? Is it true when you negate it? Is it true when you move it around and negate it? Right? What happens in this process? So let's get right to it. We're going to do one example, and I'll show you how to do the converse, the inverse, contrapositive, and then at the end, I'll give you one example for practice. Let's get right to it. So here we have the example that I started off with. If it is raining, then I will carry my umbrella. I like to start by separating these as the letters that I'm interested in. So this is P, and this right here, right after then, is Q. Now, if you look at it, the converse rule says you're going to switch the order of Q and P. So now instead of saying if P then Q, like we do here in the original statement, now we're going to say if Q, then P. So we're going to write just that. If, and I will write the last part of the statement. I will carry my umbrella. Then, there's a comma here. Then I'm going to go backwards with P. It is raining. Now, I'm going to start by analyzing the original statement. If it is raining, then I will carry my umbrella. I'm going to say that that's true. I'm going to be a responsible human, and I'm going to say when it rains, I'm going to carry an umbrella. That isn't always the case, right? But let's say that this original statement is true. Is the converse true? If I will carry my umbrella, then it is raining. False. Why is this false? Well, unless your umbrella has magical powers, it cannot make it rain. You carry an umbrella outside, could be for many reasons. Maybe it's hot, maybe it's very sunny, maybe you're at a football game and you're trying to provide some shade. Carrying an umbrella does not make it rain. Only I do. Make it rain, baby. Anyway, let's try another example. This is the converse. We switch Q and P. So the inverse, if you look at the rule, P and Q stay the same. P implies Q. But now we're going to do the opposite, right? The word inverse makes me think of opposite. So now we're going to do the opposite of P and opposite of Q, which is the negation. So I'm going to take the original statement just as is. This is, sorry, let me go back to blue. This is P. This piece is Q. And we need to negate it. We need to say the opposite of P and the opposite of Q. So we need to insert the word not in front in the first part of the sentence and the word not at the second part of the sentence. So if it is not raining, then I will not carry my umbrella. And let's write that out. That is going to be my statement. I just have to write the not in front of both statements. So if it is not raining, keyword here, then I will not carry my umbrella. Is this true? That's what we're trying to question this whole process. The original one is true. We established that. If it is not raining, then I will not carry my umbrella. This is also false. Like I said earlier, if it is not raining, it could be very sunny, and you just need some shade, right? Maybe you're going to watch a football game, or you're going out to the track and watching like a race or something. People carry umbrellas for many reasons when it's not raining. So that is false. Let's talk about the contrapositive. Now, the contrapositive is both of the previous rules. If you look at the original statement, we have P implies Q. So the first thing we're going to do is we're going to switch Q and P. I'm going to put this in green. We're going to first do the converse by switching Q and P. See how we switch Q and P? And then we're going to negate it. We're going to do the inverse. So we're going to make it not Q and not P. So by doing both rules, converse, you switch the order, and inverse, you negate both of them. We call this a contrapositive. Okay, so let's go to our statement and see what that sounds like. P is in the beginning, Q is at the end. So I need to switch the order and negate it. So I'm going to first put the not in there. I will not carry an umbrella, and then it is not raining. Okay, and when I write this statement, I need to start by writing the last part first. The last part needs to be negated, which I did here. So I need to start with, if I do not carry my umbrella, or if I will not carry my umbrella, which, you want to write this in English that it makes sense. If I do not carry my umbrella, that's how I'm going to start off. Then I talk about the beginning. It is not raining. The reason why I'm underlining the not is so that I can remember that I'm supposed to do the opposite of both statements. That's the only reason, right? So, is this statement true? We know this one is. If I do not carry my umbrella, then it is not raining. Now, the thing about contrapositive is because you're doing the converse and the inverse at the same time, the statement gets a little bit trickier to understand. Okay? So the thing I want you to know is that when you think about this is that the contrapositive and the conditional statement, the original and the contrapositive, will always have the same validity. So if the contrapositive is, if the original is true, then the contrapositive is also true. Now let's think about it a little bit. If I'm walking outside the street and I'm not carrying an umbrella, then it's probably not raining, right? Assuming that you check the weather and that you've gone through it. Yeah, if I don't carry my umbrella, then it's not raining. One will then cause the other. So this is conditional statements. We have converse, inverse, and contrapositive. And we're doing those three different rules, these related conditionals, to the original condition and assessing the validity. Are these other statements correct? So here's a practice example. Why don't you give this a pause and check out what we get. This is a math example. So if a polygon is a square, then it has 4 sides. So go ahead and pause it. Remember that the beginning part is P, the last part is Q. Go through the 3 rules, write your statements, and then check back in, right? Whenever you're ready and you're done, press play and see what the answer is. All right, here's the answer. Remember, polygon is a square, this is P, then it has 4 sides, this is Q. As I'm writing the converse, notice how I go, if it has 4 sides, that's Q, then it is a square, that is P. Now, if we assess the original statement is true. If a polygon has a square, then it has 4 sides, right? A shape that has 4 squares has 4 sides. It's true. A square will always have 4 sides. Now the converse, if a polygon has 4 sides, does that mean it's a square? Not true. And we'll talk about polygons later, but think about a rectangle, has 4 sides. Think about a rhombus. Think about a diamond. Think about a parallelogram. There's a lot of different shapes that have 4 sides, and it's not a square. The next example, we have the inverse. So we keep P and Q the same. This is P, but notice that the not makes it not P. And then the last part is also Q, but the not makes it not Q. We keep P and Q in the same order. We're just negating both statements. So now is this true? Take a second to think about it. If a polygon is not a square, then it does not have 4 sides. Pick a polygon that is not a square, like a rectangle. Does it not have 4 sides anymore? False. That's how you check the validity. Pick something that makes this true. And if that thing is true, then the last thing should follow. But I'm following something here that's not a square, like a rectangle or a rhombus, right? And I want to check to see if this is not true as well. That's what I call a counterexample, which we spoke about previously. So if it's not a square, that right there is the lasagna that I'm making. It's this really, really good lasagna made with it's like a keto diet thing. Delicious. Anyway, if a polygon is not a square, then it does not have 4 sides. This is also false. And my counterexample to prove that it's false is a rectangle, right? It does have 4 sides, and that's not true. Contrapositive. Here we're switching the order and negating it. So notice how here, at the beginning, we have Q, but it says not, so opposite of Q. And the end, saying that it's not a square, saying it's not P. If a polygon does not have 4 sides, then it cannot be a square. And that is true. Because if it doesn't have 4 sides, maybe it has 5 or 6. Is that going to be a square? No, absolutely not. And then again, remember, the original statement and the contrapositive will always be the same. If the original is true, the contrapositive is true. The other ones in the middle, converse and inverse, sometimes they're all true. Sometimes it varies. It depends on the example. All right, I hope this has helped. Please let me know if you have any questions. Leave comments below, like, and if you haven't subscribed, I don't know what you're doing. All right, guys, we'll calculate later.